Welcome to Beyond Blueprints. I'm Andrew Smith, and today we're delighted to be joined by Rajat Kulshrestha from Space Machines, CEO and co-founder of Space Machines. Great for you to be with us, Raj. First thing I want to ask you, Space Machines, it sounds incredibly cool. Is what you're doing as cool as what it sounds like?
Well, firstly, thanks for having me on this podcast, and very nice to meet you, Andrew. Yes, it is. It is cooler than it sounds. Space Machines as a company started with the premise that as the number of satellites grow in orbit, we're going to need to service them, and we're going to need to protect them, and we need to make sure that all of these satellites are operating safely and sustainably. And so, our product is really about providing almost like a roadside assistance for space. How do we service satellites that are broken down, or upgrade them, or refuel them, or make sure that they get disposed of sustainably?
That's amazing. It's really interesting to hear you say that because we have an old saying, and I'm very much on the aero side of aerospace. With the old saying, "There's no hard shoulder at 30,000 feet." But it sounds like if you go to low Earth orbit, no, there could be, and
Exactly.
that's where you come into play.
Absolutely. And I think it's changed a lot. And I give you an analogy of in the 1950s, if you were trying to climb Mount Everest, you would need 900 people, and you'd be carrying 13 tons of gear, and you just wanted to survive and get to the top. And today, in 2023, that is $6,000 for you to climb Mount Everest. And that's come as a result of a lot of infrastructure, a lot of work that's been done as far as technology innovation over a period of 50 years to make that accessible to people, affordable and available for people to do. So I think, from my perspective, space is moving from a mission centric place to a network centric place.
Okay, okay. And I mean, this idea of orbital servicing. When did you have this aha moment? When did space machines kind of come into being?
Okay. Well, it's going to sound like a cliche, but the founding story is that it was a Friday night, and I was watching one of the Star Trek episodes, and
Oh, brilliant!
there was one of the Enterprises going into a star dock, and we're like, you know what? Like, I think spacecraft will be serviced in orbit, and we've got to make that happen. And so that's where the journey. And my co-founder George, he's an amazing and a very excitable co-founder, and I need that. And he said, "Yeah, let's build that." And so that's where we started.
Oh, amazing. And in terms of just to give people at home an idea of the journey that you're kind of going on, what are the, I guess, timescales? When are you targeting getting kind of initial, product or demo to orbit?
So look, the first spacecraft, which is a tech demo, is almost completing integration, going to testing at the end of September.
That's an
It's
exciting
launching
time then.
February. Yeah, it's launching February 1, 2024 on SpaceX. We call it Optimus, and it's going to be Australia's largest designed and built in here on the ground satellite ever done, which is a great outcome for Australian space. And yeah, so we hope to demonstrate a lot of the capability that we're wanting to build into future vehicles as part of this first demo.
Okay, amazing. So, I mean, that's coming around pretty quick then. So, is it kind of crunch time at the moment with all the integration in the race towards the milestone?
Absolutely, it's crunch time and more. I think the team's working 24/7, and their heads down. Every day we've got a famous quote from the Martian movie comes to mind, like, if you solve enough problems, you get to go to space. And so we're solving a lot of problems every day as they pop up.
Okay, brilliant. I want to ask more about your team shortly, but and this is probably naivety on my part, but in terms of I guess the problem that you're solving, um, I'm interested to know how much is the interest in covering life extension for satellites that have already been designed, and this is going to be almost an extension to their capability. And how much are you thinking? Oh, actually, we can offer this to people who are designing their satellites now, so that they don't have to have this capability themselves on board if it's only something they're using once in the lifetime of the satellite. Where's the balance between those? If you can answer, if you're happy to share.
Absolutely. Absolutely. Look, I think our model has been, and you're absolutely right. I think we've got to characterize every satellite that's going up, right? Everything from a 3U satellite to a multi ton geo satellite that's servicing critical communications. And the approach that we've taken is to really look at the type of satellites and constellations that impact our life on Earth. So start to look at GPS satellites, SATCOMs, defense comms, Earth observation that do natural disaster report data analytics. So when we start to look at what happens if one of these satellites goes down and what's the impact, right? And so really bring that into play to provide some of these life extension, inspection, and other services, and make sure that's core part of where we're targeting. And so a good metaphor for that would be we're starting to provide roadside assistance in space, but we're starting with police cars and trucks and fire engines and utility trucks that provide all of that. And I think once we've proven that model with those critical infrastructure pieces, then we can start to make it more broadly available to other satellites.
Yeah. Okay. So you're keeping the key infrastructure alive first and foremost. You're kind of we have I guess the RAC over here, but you're the you're the kind of the elitist RAC.
Well, and look, I think, I mean, I'll give you in the probably in the last 3 4 months, and the example that comes to mind, at least in Australia, was that one of the GPS satellites went down for 2.5 hours, and all of the trucks all of the harvesters in fields that were doing automated harvesting just came to a grinding halt. And the estimated cost of that, for a multi-day would be at least $1 billion a day type of scenario. So when we start to look at some of these satellites and what depends on them, and the impact it will have for those services to not be available, that's where we see a real first early adopter use case for what we're doing.
Okay. It's fascinating. I really want to ask about the team, but another technical question has just popped into my mind. It's really interesting. You 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 touched on it slightly already that you're having to look at the array of satellites that might require this. I guess the analogy is you might have a gigantic bus that breaks down, or you might have a moped, and you've got to be kind of agile enough to cater to both of those. That's quite a challenging kind of requirements set to cover. Is that something that you see as a challenge? Is that something that really energizes the team? That it's not a simple fix.
And look, absolutely right. And I think it will take time to get to be able to in a place where you could roll up to a two-wheeler, the same analogy, roll up to a two-wheeler and get it back on the road versus a bus. But I think there's some common things that you start with: the ability to get very close and inspect what's going on and diagnose what's wrong with the satellite, and then figuring out whether that satellite needs to be moved out of its orbit or stay there. So I think starting to address some of those capabilities is probably going to be the first few steps, whilst you sort the issue of standardization. How do you build satellites that are serviceable, whether that's a small one or the big one? So I think from my perspective, the team's really energized in understanding how we provide that base level of capability that at least lets our customers know what's happening. So great example is Viasat. That satellite that stopped operating because the antenna didn't fold out. What's the chances of getting very close on orbit and starting to inspect it, and how does that help insurers and operators understand what to do next? And so from our perspective, there are a common set of capabilities that will drive adoption of new technologies to help us service a moped and a bus, and address some of those challenges.
Okay, brilliant. And that gives a really good flavor of the problem that Space Machines is trying to set out to solve. Let's come back to the team, because I gather you're a pretty distributed team. Can you speak to kind of the size and distribution of where I think on your website you call is it space mechanics? I think I saw you referred to
It's
yourself.
it's space machinists.
Space
Um,
machinists. Sorry, yes. Where are your space machinists based?
Sure. So at the moment, we're spread across three main locations. One is in Adelaide, in Australia, where we do a lot of our mission control and mission ops. In Sydney, in Australia, where we do manufacturing assembly, and in India, where we do a lot of early R&D and component manufacturing. Outside of that, we've got contractors in the US and Europe, and so it's pretty distributed that way. And so in total, I'd say probably around 40 people spread across those locations.
Okay. So, I mean, I guess in your startup journey for the team size, you are remarkably kind of distributed. So, you must be great at collaborating, or that must be something you really had to nail early on.
Look, it's not been a smooth journey, right? I think for us, distribution was, we started the business in 2019, 2020, COVID. So we had a lot of engineers that were remote early on, and it was just organically built that way. But we learned a lot. Like we learned things like, initially we were dividing our design build test cycle across different locations. And what we realized very quickly is that we've got to do it differently. We've got to make sure that design build test remains at the same place. Maybe we slice it differently in terms of function and what capability we do in a particular location. So I think it was learning that we had a scenario where something would get designed and then it would get built in India and then it would get built in Sydney. We realized there were some defects. Then it went back to India, and that was a massive issue. So there was a lot of learnings during that journey. But I think we're starting to get to a place where we think we're starting to get to a steady state of how we operate across the different locations.
And how does it work, as well as the geographic challenges with, time zones? Do you have to kind of have these key kind of interface times, or how do you manage that?
So at the moment, we drive a common set of interfacing during the week and a cadence that sort of drives all of the teams where they get to sync up on major issues and blockers. And then they run into their own sort of weekly cadence individually at location. So, giving a lot of time to make sure that, you align on the critical pieces, and then sort of drive your own individual design build test cycles or research cycles that happen at every location. And so I think to your earlier point, over communication is a value to the company, right? Like the more people are talking to each other, the better it is. And so our sort of ability to you know continuously reinforce things that people are working on is a really important asset.
So it sounds as if as you've gone along, you've not kind of stuck to the model. You've kind of adjusted and tweaked the formula as you've gone through to see what works best for. I guess the team that is doing different functions in these different places, but then has to have these key times to be able to share a common source of truth.
Yeah, look, and for us, it's at multiple layers, right? It starts at individual level. So we think about the type of skills that each one of our engineers needs to have. So each one of them, irrespective of what they're working on, needs to be a systems engineer. Like they need to make sure that they're thinking about the whole picture, not just their part of the picture, and really question and negotiate with others. So skills of making sure that each one of the technical leads is a project manager, is a systems engineer, is a great communicator, is an essential part of that baseline. And we've improved on that over a period of time. And then moving on to the next level in terms of process, when we start to think about what process we apply. So whether we need to be compliant to a certain standard, and how do we modify that so that it fits into our delivery cycle, right? And how do we think about those standards? And from my perspective, that's really driven by the outcome we're seeking. So hey, if we need to get this product out by that date, we will obviously modify the process and adapt it to make sure that we hit that outcome, given we're a startup. And in that process, make sure that we're doing things safely and in a way that's sustainable, but make the right set of trade-offs on the process side of things. And then I think the final step is technologies, the tools that we use and how we use them, and making sure that the tools really reflect the way we operate. Not sometimes tools tend to dictate the way they need to be used, and so really making the choice on the right set of tools that allow us to adapt them to our process.
And really interesting point on tools, because often we think about kind of in hardware terms this question of do we build it or do we buy it, which I imagine is even more important when you're at this kind of growth phase. So when it comes to those tools and how you work together and how you collaborate effectively, have you had any challenges there where you think, gosh, do we build exactly what we need or do we go out and find it? Is that a journey you've been on?
Absolutely. Look, I think there's been, I'll probably say every 3 months we get to a point where we go, if I just had this tool, and should we spend some time building it, because then we would have exactly what we need, versus going out and trying to fit our requirements into a tool that's out there but probably meets 50 to 60% of what we need, and then on top of that a layer of cost and what that costs us on an ongoing basis. So I think it's a thing that you struggle with, but I think from my perspective, it's when you start to understand the constraints of those tools, and where we've gotten to is to say, well, we understand that we're never going to be in a place where we have one or maybe two or three tools that solve it all, but we're going to have to be practical, and we're going to adopt them to the best of their abilities. And yes, that makes our world more complex, but let's deal with that complexity rather than try to build it ourselves, because that would be a whole lot of, that would be a very different thing to do.
Yeah, it's finding that sweet spot. I definitely relate to that point because I've worked in quite small teams in a big organization where there is quite a heavy-handed sometimes corporate tool, and it's that balance between do I try and chip away and customize it for exactly what I need, or do we just scrape the decks and just
Absolutely.
carve out the time so we can build exactly what we like. And it's difficult because uh, time's ticking and you don't really know until you've got to your end state what was the right answer.
Absolutely. Look, I completely agree with that. I think we've been on that journey. We're still on that journey. I think, where we are, we're embracing the chaos a little bit, but we're checking ourselves to make sure that that chaos is only exists to a certain outcome, and that we're not being dogmatic about one tool or the other. We're just doing the things that allow us to get the outcomes we need at the moment.
Yeah, yeah, really interesting reflection. I want to circle back slightly and talk a bit more about your past, Raj, because this isn't your first rodeo. You're an experienced founder, and you've been, I guess, both in the software space and now very different challenges in the hardware space. How has that move between the two? How much has been transferred, and how much has been a learning curve in the different domain?
Yeah, look, I think when I look back, I think I trained as an aerospace engineer, so I'm really hardware, and then spent a lot of time in software. And I think what software did, it's a very different domain, so changes are not easy, right? Like you've got to, you can't just do another Git request and change the code and everything starts working differently. So there is a little bit more of really deliberately thinking about the changes you want to make. So a little bit looking into the future and going, this is how we need to plan ourselves. But I think a lot of things that were part of the software domain, and I think obviously SpaceX has been a big sort of demonstrator of that, is you if you translate them appropriately, they actually serve to your advantage. The thing about focusing on building, right, and using building as a way to design and refine. So where initially, in a hardware world you'd have 40% design time and maybe another 30% build time, another 30% test, or some combination of those. You move to 20% design, 40% build, and a 40% test to to that software cycle approach and a very agile approach. So I think on the process side, it's helped us. I think where there's been challenges is then translating that into working with hardware vendors and lead times and all of that to and making that happen. And then on the other side, I think a big part of that is engineers, my generation, and even today, a lot of the engineering schools, they teach you a risk zero approach for hardware, which which is like, you cannot have any risk in your hardware systems because you just don't want it to fail. They do not teach you how to use failure as a way to design and move fast and iterate. And so I think having to reprogram some of our team to operate that way who have come from a hardware background. I think software engineers get that very quickly, whereas I think hardware engineers take their time to transition to that. But it's happening now. So I think, for us, it's been amalgamating the software and the hardware teams to actually share how they operate. And so, I've got a very specific example where we spent 4 months optimizing a piece of structure that weighed 40 kilos down to 36 kilos. And nobody asked the question, like, 4 kilos on SpaceX costs $20,000. And we probably spent $80,000 optimizing it, and nobody just said, well, should we be doing that? Right. Does that make sense? Right. And so I think that's changing. I think that risk zero redundancy approach is very hardware, legacy hardware engineering approach. And so I think where software's um, that background software's work really well is to really look at those problems slightly differently. um, but also then on the other side, sometimes it's worked to our detriment, where we've moved fast and made mistakes and realized, well, some things just take time, so let's not try to optimize things where software is not a great analogy. So it's just picking and choosing where certain things from software work.
The right tool for the job. I've heard that kind of that SpaceX philosophy before, which is you can have as many models as you like, but nothing beats a test if you want to move fast, because you could be polishing the best model ever, and then you get to your last 20% of your time, and if it deviates, you've just used a
Exactly.
whole kind of iteration cycle to do it. So yeah, really interesting. Um, that you talked slightly about kind of supply chain, this hardware challenge, space. Am I right in thinking you're kind of the first kind of space startup that's really doing hardware in the Australian space
Yeah.
at the moment? So how have you found the US, I guess, approach to space versus what's it been like moving down under?
Yeah, look, I think it's very different. U.S. clearly has 50 years, 60 years of space background, space infrastructure, um, people infrastructure. Like, people have trained to be aerospace engineers with generational families who've trained in that. So I think for us, whilst we're trying to build a product as a company, we're actually also building some infrastructure which doesn't exist. So, I had a really interesting anecdote where one of the companies in the US, they were looking for cryogenic valves for their engines, and they just went to the Apollo graveyards and found themselves a valve, and they were just able to pick that up and test with it. Whereas, in
Nice
Australia,
gig if you can get it.
yeah, and we're like, we don't have that, so we don't have that heritage, and so we've got to start to look to build it from scratch. So we depend a lot on collaboration, working with companies in other continents, other geographical regions, where we can leverage what's already been done, and really curate and put together and manage that supply chain very effectively.
Okay, so it's yeah, interesting. Very, very different environments. If only we all had some Apollo hardware to dig into in the garden.
That would
Um,
be
yeah. And another, this brings me back to a technical angle, which is, are you planning to launch from Australia, or kind of orbits wise, is that not favorable? Will you be looking for, or will it depend on the mission that you're trying to assist?
Look, obviously, there is Gilmore Space that's building Australia's rocket capability. We're one of their first customers, and we really support launch from Australia. I think it'd be great to see a launch from Australia. So we're really hoping that they've got a launch plan soon, one of their first ones, and we're fingers crossed that we'll build that capability in Australia. I think, though, we see the orbital servicing and protection sort of framework applying globally. And so one key part of our platform is being compatibility with different launchers out there from different countries, so that we can provide our network the best, the most largest and more broadest frame of orbits possible, to service some of the satellites on orbit.
Yeah. Okay. No, that makes total sense. When when you're going to assist these satellites, another technical kind of thing that's coming to mind, and you slightly touched on it earlier, about kind of the, the the risk approach that you take to space. I guess from your customer's point of view, trust is going to be really important because they've got this precious asset, and you need to get into the nitty gritty to fix it, refuel it, whatever it is. How do you go about building trust? Is that something you're having to start really early in the conversations with customers?
Absolutely. Look, and I think that's why that approach of starting to build iterative capability that brings confidence from our customers. So, for example, our ability to get on orbit with an asset and get close safely starts to build confidence in our customers, and our ability to uh, high resolution characterize the asset, make sure we understand what the orbits it's at, how it's moving. All of those things start to build trust in our customers. And so I think then once that's happening, then we can start to look at, okay, now we're going to go proximity and start doing proximity ops and really start to look at some of those use cases around being able to put a new module in or repair it or refuel it or dispose of it. So, you're absolutely right. I think we see this as a long-term relationship with each one of our customers.
And it's, yeah, about kind of demonstrating the precision and control you've got to bring them on the journey with you.
Absolutely.
um I don't know how much you can speak to customers. I know there's kind of commercial confidentiality, but I can imagine there's an interesting kind of dual use case for the technology. So are you let me leave it as an open question for you. What can you speak to the customer, I guess, interest that you're having? Does it cover a broad church?
Sure, absolutely. Look, and going back to the capability of the platform, and it comes down to we want to service and protect critical space infrastructure, right? And so we start with what is critical space infrastructure today. So we look at telecom satellites in geo, we look at communication satellites in leo, we look at capability that provides our defense forces with certain capabilities. And so when we start to look at that gamut of critical space infrastructure, our customers are commercial or on the dual use side. And it's really around the way I think about it is how do you enable sustained and safe space operations, right? And the customers that talk to that globally. And so, you know, what I would probably say is um, satcom providers are an interesting customer segment for us. And then also some of the national security agencies around space are customers of ours. And so those two really form the current basis of a lot of our business. It's expanding because you're seeing more and more satellites. I think over the next 10 years, there's going to be a 4x increase in the number of satellites. And a lot of that will be critical space infrastructure, weather satellites and natural disaster satellites. So, really where there are satellites that are impacting human life and are critical to our way of life is where we see customers emerging from. So, government defense, and commercial satcom operators is where our business is at the moment.
And is Space Machines also going to speak to the challenge of space debris? Because I've seen some of the scary simulations about how that is kind of growing, and that I believe there's now some sort of mandate. If you're putting a new satellite into orbit, you've got to have some sort of plan to remove it. Can Space Machines help at kind of that end of the life cycle as well?
Absolutely. And look, I think that's where our model, when we looked at our model and how it was similar to what roadside assistance does, I mean, it would be pretty bad if your car broke down in the middle of the highway and you just left it there, right? And so our view has been that, we want to work with national space agencies out there, and very similar to the way your cars get registered. And I'm sure everywhere around the world where when you register a car, you need to make sure that you have a third party service that allows you to have roadside assistance as a mandatory part of you getting your car registered, right? Because it's for the common good of everyone that if there are multiple cars that are starting to block highways, that it's a common asset that should not be blocked. So I think debris removal is a big part of our long-term vision and the way we work with government agencies globally around it.
Yeah. It's such a great analogy. I think you need a catchy jingle to go alongside. Although that's the next step. I just imagine you kind of orbiting someone, flagging you down as you're doing an orbit past.
I don't want
Um,
to say it too loud, but the marketing guys are going to get pretty excited.
sorry. um, so I do have another question on requirements because it's really interesting to me because you have control over your product and what the space machines product is going to do, but your customers will follow different processes for either building their satellites or how they track them, how you exchange that information. Is it inevitable that a certain amount of those requirements are going to be defined on a case by case basis? There is only so many that can be generic, and then you've basically got an open scope on some of them that you've got to try and design around.
I think this is one of those things that we have and we're hoping to adopt from the way software and SaaS platforms have been built, where we're starting to think about demand and what are the features that are being demanded, and so really start to provide a baseline platform and a capability, and then test it by access and data to start building more and more capability a period of time. So I think you've got a great point that it's easy for us to very quickly get into, oh, that's what the one individual customer wants, and that's where there's a lot of um, from a business point of view, a lot of attractiveness. But I think we've got to hold ground to say, at the end of the day, platforms win out. And so our view has been, make sure that we build it in such a way that we can test for the type of things our customers want. And as we test them, as we identify demand for them, we can start to add them to our platform over a period of time. That will mean that there'll be some opportunities that we're not going to access immediately, but we believe that on a long-term basis, the way we deliver that rather than an individual vehicle, a bespoke vehicle that delivers that kind of capability is not going to be the way to go. So I think it also means that, to your earlier point, that we can take control of the way we build, right, and the process we apply to build, and so that gives us a lot of efficiency, and so I guess it offsets against the cost of building a platform versus servicing a very specific customer need now versus a larger need in the future.
Yeah, it's fascinating kind of a problem you've got because you've got to keep that open scope. I mean, speaking to the future, so you've said 2024 is when you're kind of planning to launch first product. What do you see as the future of space engineering? What's your golden vision? What would you like to see happening? Do you think it's happening where we're going? Are we in the right direction?
I think we're moving in the right direction. I think space engineering was always treated as an exception, right? Like, it was like, all right, it's a very specific thing out there, and only certain people can do it. And so we're finding that it's becoming more democratized, right? There are people that are coming from non-space engineering backgrounds are getting interested in it and applying the learnings they've had in those areas into space. So before, space was sort of a playground for a few, and I think from our perspective now that's expanding, and the more it expands, the better it is for everyone because you get a very diverse set of views on how to build. I can give you a very good example on our first spacecraft. So, all spacecraft have to be wrapped in a multi-layer insulation for thermal management. And being a startup, we just did not have that capability here in Australia, and we couldn't access one. And so, when we were thinking about how to do MLI, which is the multi-layer insulation, and it had to be 15 layers, we're like, look, this is foil. We need to stitch it together. So we actually got a seamster, right? And literally, there was a sewing machine in the lab, and we sewed it. And we're in a place now that our multi-layer insulation looks beautiful. Like, it's so perfectly fitted to the spacecraft, and so for me, it's been amazing to see that a Seamster now is doing space engineering, and that's phenomenal, right? Like, and I think broadening that group of engineers who work on space and non-engineers who work on space is where this needs to go, right? Because then everybody can work on a space system.
I love that idea. Just like a nice little knitted jacket to keep the spacecraft cozy. Well,
It was
well,
literally that. It was literally that, and I think if you actually check the pictures out on some of our posts at the moment, like you'll see, like we've got feedback from space engineers going, "This looks beautiful," and so our view is that I mean, circling back to, I feel everybody, it's when every engineer or non-engineer thinks that they can participate in the space engineering and space systems business, is when we think we're going to have a lot of innovation happening.
yeah, yeah. Oh, it's very, very exciting. Um, and- but before we wrap up, there's something we'd like to ask everybody on Beyond Blueprints, which is, and it's a slightly spiky question. It's a bit of a thought provoking one. Is, you know, how are you tackling this problem now versus if you were tackling this in, say, 1985 or 30 years ago? Are you tackling it in the same way, or is it fundamentally different? What's changed in that meantime that's enabled space machines to be as it is today?
Yeah, look, um, I think there's probably multiple layers of answers to this, right? I think what for example, cost to access space has gone down significantly, right? That's opened up huge avenues of our ability to take risk and what that means and cost associated with it. I think the focus on the miniaturization of electronics has had a huge role in it. I think again, democratizing who can build a system has had a huge impact on it, right? Like, you've gone from NASA and ESA and others in a very select group of people working on these systems to you know in an average person being building a 3U CubeSat, right? And so I think that sort of capability is increased, and also I think the commercial off-the-shelf technology available to do things as a result has allowed people to build these systems fast. They don't have to be built specifically for space. And I think maybe I answer this question looking into the future. Like, if you think about Starship, Starship is going to bring the cost of launch down to 500 to $8,000 a kilo. So now, if you're building a lunar rover right now, you would build a very specific lunar rover for space. But if it only costs you 500 to $1,000 a kilo, you would take a rover that's already available commercially and you would adapt it for space use, because now you have the volume and the mass and it's not that expensive to send it. So I think there's another revolution coming as we move to the next phase of access to space, right? Where rather than satellites getting smaller, now they're going to get bigger, and in getting bigger, you might actually be able to use a lot of technology we've built already for terrestrial use, just get adapted for space use. So I think you know it's these changes that happen as a result of process and technology commoditization that's driving the difference between 1985 and us.
That's such an interesting point. So you think the trade space might actually be changing in terms of that balance between weight and readability? I guess you think yeah, we're going to see that trend maybe changing slightly.
Well, I mean, if a great example of that would be if you have a battery management system for a 2 kilowatt, battery, right? Now you could take one that's terrestrially being used, qualify it for space, not have to mass or volume optimize because it's only $500 and $1,000 per kilo you're paying for it, versus a world where you're paying 15 to $20,000 per kilo, and that place you would absolutely have to look at completely redesigning in a new way. So I think suddenly you can leverage and stand on the shoulders of technology that's already been built for Earth, right?
It's yeah, exciting new frontier. Moving away from where every gram counts to where space is much more democratized. It's an exciting time to be in the industry. Thank you so much, Raj, for joining us on Beyond Blueprints. I'll be keeping my eyes eagerly on the news next year. So best of luck with the first launch, and thanks so much for joining us today.
Thank you for having me, Andrew. Really appreciate it.